Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at Form 1 chemistry, and we are going to be paying attention to the topic of water and hydrogen. And specifically, we are going to be discussing the preparation of hydrogen gas in the laboratory, and then finally look at the properties. But as for this lesson, we will start by first looking at the preparation of hydrogen gas in the lab, and then we are going to dive into some questions. So we are going to look at the preparation of hydrogen gas, eliminate and look at the best methods to prepare hydrogen gas in the lab, and also discuss why it is not possible to use other methods. So let's begin. So first you start with the laboratory preparation of hydrogen. So hydrogen does not exist freely in nature. It usually exists in combined states, such as compounds like water, like sugar and fuel and other compounds as well. But in the gas, we are able to prepare hydrogen using different compounds. So hydrogen is usually prepared by reacting acids with metals, and specifically we are going to be talking about dilute acids. So we'll be taking dilute acids and reacting them with metals. But the most suitable acid we are going to use is dilute hydrochloric acid, and dilute sulfuric acid is also suitable, and it is called dilute sulfuric 6 acid. Although there is an exception in the reaction of dilute sulfuric 6 acid, but we are going to discuss it later on. And then the most suitable metal is zinc metal. We are also going to see why other metals are not that suitable. So when you look at the laboratory preparation, the first thing you can see on the conical flask and the dropping panel, we have some zinc granules added to the conical flask, and then the dilute sulfuric 6 acid is added on the dropping funnel. We also add some copper 2 sulfate. We are going to discuss what the function is later. And then also the copper 2 sulfate is going to act as a catalyst. So the reaction can actually start and continue on its own. But if we want to speed up that reaction, we can add a catalyst. And this catalyst in this case will be copper 2 sulfate. And then the resultant gas was collected by overwater method, and the reason why it is collected by overwater method is because it is insoluble in water. It is one of the gases that can be collected by overwater method. And then finally, if the gas would be required dry, it's going to be passed through concentrated sulfuric acid. So if we were to use concentrated sulfuric acid, we are going to place it in a conical flask containing concentrated sulfuric acid. And then we will introduce a delivery tube that gets into the concentrated sulfuric acid, and another one on top. And then we are going to collect the gas. And you can see the gas is being collected by upward delivery. This is a method called upward delivery or downward displacement of water. And the reason why it is being collected in this manner is because it is light, very light. It's actually one of the lightest gases known. So you can call it downward displacement of air because the moment the gas gets in, the air is displaced on the downside. That's why it's called downward displacement of air. So alternatively, anhydrous calcium chloride can be used in a U-tube, as you can see. So the calcium chloride is placed in the U-tube, and then a delivery tube is placed, and the gases just passes in the tube, and then it's collected by upward delivery. So these are the two compounds that are used to dry hydrogen gas. So one thing to note when it comes to the preparation of hydrogen gas, We said that the most suitable acids are the hydrochloric acid and the sulfuric acid, and that are dilute. The reason why we do not use dilute nitric acid is because it's not that suitable. If it is used, what happens? It is oxidizes the hydrogen gas that is being produced to form water. So we usually say that nitric 5 acid is a very strong oxidizing agent. You can see it oxidizing or adding oxygen to the hydrogen to form water. It is a very strong oxidizing agent. Another reason why we cannot use potassium, sodium, lithium, and calcium, because we said the most suitable metal is zinc. So these metals are not that suitable in the preparation because they are very explosive in nature. So if they explode, this can be very dangerous in the laboratory, so we do not use them. Then also magnesium is not usually used in the preparation of hydrogen because it is very expensive. For magnesium, it's not that explosive, but it is very hard to purchase, and so it is not that locally available for most labs. Then other reasons, the reason why we don't use aluminium metal is because that reaction will not occur until it is washed. And we see we are washing with concentrated hydrochloric acid. Why are we washing? We have to wash it to remove the oxide layer. This is one of the reasons we said aluminium does not react quickly with steam. So it is also one of the reasons why it may not react with acids that quickly. This oxide layer needs to be removed before the reaction is allowed. And then also we do not use the iron metal because it usually produces a mixture of gases, and one of the gases it produces is has a foul smell. The reason why it produces a mixture of gases is because the iron itself contains impurities. So the foul smell is because of the production of hydrogen sulfide. So we have some sulfide impurities on the iron metal that in turn react with the acid, maybe the specific acid that we are using. For example, if we react iron with sulfuric 6 acid, it's going to form iron 2 sulfate and hydrogen gas. But this is not the only reaction that is going to happen. Also, the impurities in the iron are going to react with sulfuric 6 acid. And you see this iron sulfide, which is one of the impurities, reacts with sulfuric 6 acid to form iron 2 sulfate, hydrogen sulfide. This is the one that is causing the foul smell. And then finally, other sources of hydrogen are usually cracking of alkanes. This we are going to discuss later on in Form 3 in details on how we can be able to obtain hydrogen. So next, let's look at one question in regards to what we have discussed. So the setup below was used to prepare dry hydrogen gas. Study it and answer the questions that follow. So we have the dilute sulfuric acid that is in a dropping funnel, and we have the zinc granules. And then there is a delivery tube that is going to the conical flask. The conical flask has liquid Z, and then another delivery tube goes to the cardboard. So the first question is identify one mistake in the setup. So the first mistake we note in this setup is the method of collection of the gas. So you write the method of collection, and then you will further go on to mention what's the problem with the method. So in this case, we say the method of collection of gas, hydrogen is not collected by downward delivery. So that is one of the mistakes that we have noted in this setup. Next question is, what is the role of liquid Z? So you can see the liquid Z has been put side by side with the collection method. So it tells us that this gas has to be dried for us to collect it in such a manner. So it means liquid Z is a drying agent. And the most suitable drying agent is, in this case, if you were asked, it would be concentrated sulfuric 6 acid. And finally, the last question is, write an equation for the reaction. So we have been told to write the equation for the reaction between dilute sulfuric acid and zinc. So this is zinc reacts with hydrochloric acid, and it forms a salt which we will call zinc chloride and hydrogen gas. So you can go ahead and convert this word equation into a chemical equation, especially if you have been able to do that topic in Form 2. And the next thing that we're going to discuss is both physical and chemical properties of this hydrogen gas that we have produced. So make sure you're able to see the reason why some metals are not that suitable, because you do not know which metal is going to be presented for you in the tests. So if you are given some metals that are not suitable, make sure you're able to explain why. And also why some acids, especially dilute nitric 5 acid, is never used because it is a strong oxidizing agent. As for the sulfuric acid and the hydrochloric acid, they are commonly used. We only have a few exceptions. And when it comes to dilute sulfuric acid, we cannot use dilute sulfuric acid with the metal called barium, and we cannot use dilute sulfuric acid with lead. The reason why we do not use dilute sulfuric acid with these two metals is because they form insoluble salt. And when these salts form, the reaction will start and then stop. This is discussed in details also when we were doing acid-base indicators, and when we were discussing the reactions of metals with acids, we also discussed that. But as for now, it's also going to be discussed in details when we get to also Form 3 and also Form 4 and also in last bit of Form 2 in salts. So that brings us to the end. So see you in the next lesson.